Calculus examples, the chain rule. This is video 19. In example 5, y equals cos cubed x. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. Example 5 from Part 1 of Video 13. Find the derivative of the function y equals cos cubed x. Note that cos cubed x equals cos of x times cos of x times cos of x. Solution. You should try method 1 first. Then complete the exercises in Scene 3. If you have difficulties with method 1, complete method 2. Then try method 1 again. See Reminder 1 in Scene 9. Method 1. A direct method. The chain rule is the only differentiation rule that allows you to write down the derivative directly from the function you want to differentiate. The function is y equals cos cubed x. Now replace cos cubed x with cos of x all cubed. When the function y is a bracket raised to a power which is 3, the derivative of y equals dy by dx equals the derivative of the bracket raised to a power using the power rule is 3 times cos of x to the 3 minus 1 multiplied by is times the derivative of is d by dx of the function inside the bracket, which is cos of x, so substitute cos of x. Now replace cos of x all cubed with cos cubed x and cos of x to the 3 minus 1 with cos squared x. So the derivative of the function cos cubed x with respect to cos of x is 3 cos squared x. See Reminder 2 in Scene 10. Therefore, dy by dx equals bring down 3 cos squared x times d by dx of cos of x is minus sine of x. And thus dy by dx equals 3 times minus sine of x is -3 sine of x. Bring down cos squared x. The instructions above were first introduced in video 14. Now complete the 3 exercises in scene 3 using this method. In each question, write down the derivative directly from the question, omitting the line of working between them. To review the above working, you should pause this video now. Exercises. Applying method 1 to functions that involve a bracket raised to a power. Write down the derivative of all 3 of the following functions using method 1 in scene 2. If you write the above questions on a piece of paper, then display method 1 in scene 2. You can use it as a template to find the derivatives. To find each derivative using method 1 before seeing the answers, you should pause this video now. To simplify each derivative before seeing the final answers, you should pause this video now. To review the questions and answers, you should pause this video now. Finding the derivative. Method 2. A set procedure. The chain rule is: so before the chain rule can be applied, the function z must be identified. Identify the function z. Fact 1. If y equals a bracket raised to a power, then z equals the function inside the bracket. The function is: so y equals a bracket with cos of x inside the bracket raised to a power which is cubed, then z equals the function inside the bracket which is cos of x. Therefore, z equals cos of x. The fact stated above was first introduced in video 14. To review the above working, you should pause this video now. The set procedure. I created the set procedure below so that once my students had identified z, they would always be able to obtain the correct derivative. See Reminder 1 in scene 9. The question is: from scene 4, z equals cos of x, then y equals since z equals cos of x all cubed becomes z cubed, so dz by dx equals the derivative of cos of x, which is minus sine of x, and dy by dz equals the derivative of z cubed, which is 3z squared. The chain rule from scene 4 is so dy by dx equals dy by dz is 3z squared, because dy by dz equals 3z squared times dz by dx is minus sine of x, because dz by dx equals minus sine of x. Therefore, dy by dx equals 3 times minus sine of x is minus 3 sine of x times, replace z squared with cos of x all squared, because z equals cos of x, which is usually written as dy by dx equals minus 3 sine of x cos squared x. You should complete the exercises in scene 3 using method 2 now, and then try method 1 again. To review the above working, you should pause this video now. As in the previous 4 videos, if you have difficulty understanding method 1, then work through method 2 first. In method 2, you must first identify the function z in the chain rule formula. This is explained in scene 4. After you have identified z, you can complete the set procedure in scene 5. See reminder 1 in scene 9, and then try method 1 again. Every one of the 10 functions in the exercise below is similar to one of the functions in videos 15 to 19. Also, you have used method 1 to find the derivative in the exercises within these videos, so you should be able to complete the exercise below. Exercise: the 10 questions from scene 7 in video 14. State the derivative of each of the following functions using method 1. Do not forget to check your answers with the answers in scene 8. Scene 7, the next scene, contains the three sets of statements that form Method 1 in videos 15 to 19. So if you do have difficulty with Method 1, print Scene 7. Select the appropriate set of statements for the question you are attempting and hence find the derivative. You can print the screen using a piece of software called Snip and Sketch. When solving questions from your textbook similar to a function in videos 15 to 19, you will find it helpful to have a printed copy of Scene 7 referenced above so you can use it to help you find the derivative. Now you have completed all 7 videos, you should find the chain rule simple and beautiful. Cheers! Do not forget to check your answers with the answers in the back of the textbook. Method 1. The set of 3 statements for each form of y. They are displayed without commentary. To review the above sets of statements, you should pause this video now. Solutions to the 10 questions from Scene 6. They are displayed without commentary. To review the above answers, you should pause this video now. Reminder 1 displayed without commentary. To review the above reminder, you should pause this video now. Reminder 2 displayed without commentary. To review the above reminder, you should pause this video now.